Okay, good day everyone. Hey, please join me as we had a discussion about our next lesson on determinants. But first, let us define permutation and inversion. Okay, let us consider this definition. So define S sub n to be a set containing the numbers 1, 2, 3 up until n. Then a rearrangement, okay, without repetition of elements j sub 1, j sub 2, up until j sub n of the elements in this set is called permutation of S sub n. Hmm. So, say for instance, if we have set A, hmm, so if we have set A, I'm sorry for this. Hmm. Okay, if set A contains numbers 1 and 2, so the possible arrangement on this would be 1, 2, and we have 2, 1. Okay, then if we have, say, set B containing the elements 1, 2, and 3, 1, 2, and 3, so if we consider the arrangements or rearrangement of the numbers, so say we start with 1, 2, 3, then it's also possible that we have 1 followed by 3 and 2. And then it's also possible that 2 will come first, followed by 1 and 3. Then, or 2 will come first, followed by 3 and 1. Also, it's possible that 3 comes first, followed by 1 and 2, or 3 comes first, followed by 2 and 1. So in this particular um, elements, okay, so a set containing 3 elements, we have 1, 2, 3, 4, 5, and 6 possible arrangements. So we learned this idea in counting techniques about permutation, and actually, something is missing here. Okay, the set S sub n has a total permutation of n factorial. Okay, so if we want to count the number of permutation here, okay, wait, where's my pointer? So the number of arrangement that we can do here is 2 factorial, okay, which is equal to 2 times 1, and we have 2. In this case, there are 3 elements, okay, so 3 factorial, okay, which is equal to 3 times 2 times 1, and we have 6 arrangements. And these 6 arrangements are given by this one. So that's how we do permutation. And um, definitely there is no repetition of the elements, and the order of the elements is given importance here. Okay, so I assume that this is familiar with you because you had this lesson, okay, the number of arrangement. Okay, we have the lesson on permutation, we have the lesson on combination. Okay, when you took your probability class. Okay, now let us continue the discussion here. Okay, so there's some missing entries here, then followed by period. A permutation is said to have an inversion. So this is a new term, I suppose. Okay. If a larger integer comes before, okay, the larger integer comes before than the smaller integer. So it's possible that a given arrangement has no inversion. Okay? Kung walang instance na nauna yung mas malaking integer kaysa sa maliit na integer, no? Okay, but in this case, tingnan natin yung mga inversion. Let us consider this arrangement. Let me choose another color. Okay. So say this arrangement, 1, 2. Okay, for 1, 2, this arrangement has no inversion. Okay? Kasi mas liit yung 1 kaysa sa 2. Okay? So there is a 0 inversion here, while here in 2, 1, there is 1 inversion. Okay, one inversion. Okay, now how about this 1, 2, 3? So 1, 2, 3 has zero inversion. Okay, wala namang instance na may naunang mas malaking number kaysa sa maliit na number. While in this arrangement 1, 3, 2, 3 comes before 2. Okay, so there is one inversion. Okay, in the case of 2, 1, 3, 2 comes before 1 and 2 is larger than 1. Okay, then aside from this, there is no instance that the larger integer comes before the smaller one. So in this case, there is one inversion. Now in the case of 2, 3, 1, so 2 comes before 1 and 3 comes before 1. So there are two inversion. There are two instances na mas nauna yung mas malaking number kaysa sa mas maliit na number. Okay, how about 3, 1, 2? 3 comes before 1, 3 comes before 2. Okay, 1 is smaller than 2, so there are two inversions. Okay, for 3, 2, 1, 3 comes, 3 is larger than 2, 3 is larger than 1, and 2 is larger than 1. So there are three inversions here. Okay, so ganun yung pag-count natin ng inversion. Okay, tinitingnan natin kung mayroon bang pagkakataon na nauna yung mas malaking number kaysa sa mas maliit na number. So if there is, then we say that there is an inversion. And then, if we are asked on how many inversions that a given arrangement has, and we need to count, no, how many instances, okay, did it happen that the larger number comes before the smaller number? Okay? So, bakit kailangang mabilang natin? Because if we consider the next statement, no, if the total number of inversions is even, then the permutation is called even. Okay? Otherwise, it's called odd. So, kung bibilangin natin yung number of inversions, pag even number yung number, so that is an even permutation. Okay? Say, for example, here. So, 1, 2, okay, there is no inversion. 0 is considered even. So, this is an even permutation. 2, 1, there is one inversion. So, this is considered as odd permutation. Then for 1, 2, 3, there is no inversion. Okay, so this is an even permutation. For 1, 3, 2, there is 1. And so with 2, 1, 3. Okay. So for these two arrangements, we have only one inversion. So these two are even, are odd permutations. Okay, for the next one, okay, for the next one, we have 2, 3, 1, okay, as well as 3, 1, 2. So 2, 3, 1 and 3, 1, 2 have two inversions. So we call this permutation to be even. While 3 to 1 having three inversions, so we call this as odd permutation. This arrangement to be odd permutation. So I hope that this is clear with you, ano, guys. Okay? So it's important at this point in time when we have the discussion or the definition about the determinants, it's important for us, okay, to identify whether a given permutation or arrangement is odd or even. Hmm. Hmm. So I put so much space on this, but I made sure that the space is only in one. So these are additional examples, but I would like to focus on this definition. Okay? Because the lesson is about determinants. So let A be an n by n matrix. So we have matrix A, and this matrix A is a square matrix. So we're simply talking about square matrix here. Okay, so nakaisang grupo lang to. This is not applicable for all matrices. No? The determinant of A, denoted by this, depth of A, but we read this as the determinant of A. Okay, is equal to the summation of either positive or negative, but this is the product. A sub 1, J1, A sub 2, J2, A sub n, J up until A sub n, J sub n, where the summation is over all permutations, okay? All permutations J sub 1, J sub 2, up until J sub n of the set S from 1 to n. Okay, the sign is taken as positive or negative according to whether the permutation is even or odd. So we want to get the arrangement, no? Okay, kasi permutation yan. The arrangement, okay, J sub 1, J sub 2 up until J sub n, we are referring or we are looking at the columns. Okay. So for others that this sounds to be confusing, how do we get the determinants? So first, okay, we get the product. And this represents the product and these are the entries, right? Okay. We look, we, we get an element from the first row and that is represented by A sub 1, J sub 1. Okay? So we get an element from the first row, okay? Okay, but J is from 1 to n. So just take an element from the first row, and then you take an element from the second row, but from different column. Then take an element from the third row, from another column different from the ones taken on the first two elements, no? And then up until the last row, okay, the last row, then you take from different columns. Okay, maybe it would be better if I'm going to illustrate that. So say let us consider a 2 by 2, a sub 1, in general, a sub 1, 1, a sub 1, 2, okay, a sub 1, n, a sub 2, 1, a sub 2, 2, a 2, 2, a 2, n. Then we have a n 1, okay, a n 2, up until a n n. Okay. So considering that we are only dealing with square matrices here, okay, so the nth row, we have n number of rows and n number of columns. So what do we do? Say, for instance, we consider A11. So we have A11. Then we consider, we get an element from the second row, but not from the first column because this one came from the first column. Pwede natin kuhanin si A22, pero pwede rin natin kuhanin si A2n. Okay? Kahit alin dito sa mga elements na to, wag lang dito sa A21. So we have A11, sabi natin A22. Okay? Hanggang kuhanin natin ANN. Plus, ito kinuha ko, then ito. Okay, plus, pwede rin naman, nag-start tayo kay A11, pero instead of A22, kinuha si A2N. Okay, A2N, yung pangalawa. Okay, so, if we get an entry from the nth row, okay, hindi na tayo po pwedeng kumuha sa nth column. So, pwedeng kumuha tayo, say for example, A and 2, and so on. So, we continue the process, and then we consider the permutation or arrangement, okay, with respect to the columns. So, this is 1, 2, up until n. For this one, we have 1, n, okay, up until 2, okay, and so on. So, Basically, that's the process. So let's consider, what if we have a 2 by 2 matrix? So here's my pointer. Let me create a space here. So what if we have a 2 by 2 matrix? Say if we have A11, A12, A21, and A22. So what if we will get the determinant of this one? So this is equal to, first, if I'm going to choose A11, as entry from the first row, so ang entry natin from the second row will not be A21 kasi hindi po pwede, not from the same row, not from the same column. So basically, ang i-add lang na, ang isasama lang natin dito is A22. Then sabi, mo pwede naman mag-start pag sa first row, I can choose A12. Well, actually, kukunin lahat ng possible arrangements na yan. So, A12, so yung susunod na entry na kukunin natin will not come from the first row, will not come from the second column. So, ang natitira na lang is A21. Okay? Then the next question will be, what is the sign? Kasi sabi, it's either positive or negative. So we consider, ang magiging basis natin, reference natin ngayon, would be the column number. Okay, so in this case, we have 1, 2. In this case, we have 2, 1. Then, so if we have 1, 2, we try to find out the number of inversions, and then afterwards, we will identify whether the permutation is odd or even. Okay, if that is even, the sign will be positive. If that is odd, the sign will be negative. Okay, so in this case, we have 1, 2, there is no inversion. 0 yung inversion, which implies that this is an even permutation, which further implies that the sign that we will hold is positive. Okay, for 2, 1, 2 comes before 1, and 2 is greater than 1. So this implies that there is 1 inversion. There's 1 inversion, hence we have an odd permutation. Okay, and if we have an odd permutation, the sign will be negative. So in this particular case, so this is positive and then minus, okay, the product of these two entries. So to find the determinant of a 2 by 2 matrix, okay, so it's given by this. The entry in the first row, first column, multiplied by the entry in the second row, second column, minus the entry in the first row, second column, multiplied by the entry in the second row, first column. Or basically, so, ganito yung definition natin ng determinants, no? And since in mathematics, we try to find the patterns. Okay, so basically, yung A11, A12, that's the product of the entries in the A22. Okay, this is the product of the entries in the main diagonal. While this one, A1 to A21, okay, this is the product of the other diagonal. Okay, the other diagonal, A1 to A21, but the operation is, the sign is negative. So minus the product of these two entries. So for example, okay, let's go with specific. So if we have, okay, I will use this side so that you will have a guide. So for example, if we have a 2 by 2 matrix, so if we get the determinant of say 3, 5, -6, 2, okay? So this is equal to the product of this. We have 3 times 2, okay, minus the product of these two, 5 times -6. So we have 6 minus this is -30. So this is equal to 6 plus 30, that is 36. So the determinant of this 2 by 2 matrix, okay, is positive 36. So, ano yung realization natin? One important input here is that the determinant of a given matrix, kahit ano man yung size na yan, if the matrix has real entries, the determinant is a real number. We are not expecting a matrix to be the determinant, but we're expecting a number. Number siya constant, okay, or scalar, probably. So, kung ano man yung itatawag niyan, basta that is just a number. Ganon yung determinant. Okay, so let us consider, ganyan pag 2 by 2, yung product ng entry sa main diagonal minus the product ng entry sa other diagonal. And I think for some of you, you are familiar with this process. Yeah, you are familiar with this process. Yun nga lang, ganun lang siya tinuro eh. O, kunin nyo yung product na nasa main diagonal minus yung product sa diagonal up, and that's it. But, in our class, mas kinilala natin, bakit ba ganun yung proseso? Sinunod natin yung definition, at sa definition, we consider the arrangement, the permutation, even the inversion, whether to determine whether the permutation is odd or even. Okay? Now let us consider a 3 by 3 matrix. So doon tayo. Kanina, nag 2 by 2 tayo. That is the simplest. Okay. Paano kung meron tayong 3 by 3? Oops. Okay. So, i-establish muna natin yung process by definition. So, by definition, ano nga pagkuha ng determinant? Say, if we have A11, A12, oops, okay, A13, so we will get the determinant of this, A21, A22, oops, what's wrong with the pen? Or with the one right using the pen. A22, then A23. Then A31, A32, A33. Okay, equals. So by definition, we get the arrangement, no? Okay, the arrangement of these elements. Okay, if first we start with A11. Okay, A11. So we will combine this, okay, or multiply this with an entry from the second row, but not from the first column. Okay? So, hindi pwede na nasa first row, tapos nasa first row. So, second row, pero hindi natin po pwedeng kuhanan ang first column. Okay? From different row, different column. So, pwede tayo ng A to 2. Okay? Kung nakuha na natin ng A11 at A22, pag kumuha tayo ng entry sa third row, hindi siya pwede sa first row, hindi pwede sa second row. So, wala na tayong choice kundi A33. Okay, next. Okay, pero po pwede rin naman, if we choose A11, pwede naman na sa A23 tayo kumuha. Diba? Kasi pag yung second nito, second entry, basta hindi manggagaling sa first row. Paano kung sa third row natin kinuha? Pwede naman yon. Pero kung kukuha tayo ng entry sa third row, okay, erase ko to Oops. na sobra. A22. Okay, kung kinuha na natin si A11, tapos kinuha na natin si A23, okay, sa third row, hindi na po pwede makakuha na nasa first column. Hindi na rin po pwede sa third column. So, no choice tayo, kundi kuhanin si A32. Okay, A32. Okay, next. Iyon ay kinuha natin yung entry sa first row. So, pwede rin naman na mag-start tayo sa second row. Okay? A12. Okay? Kung nasa second row, second column, I'm sorry. First row, second column. Ito, A12. So, yung susunod na entry, pwede manggaling sa first column or po pwede manggaling sa third column. So, sabihin natin, A21. So, sa third row, dapat ay A21, A12, A21. So, sa third row, dapat sa third column na yon, A33. Or, that's A12, ano? Pwede rin naman, nung nag-start tayo sa A12, nung una kinuha natin ng 21, pwede naman ang kunin natin ay 23. A23. A12, A23. Okay, so, yung third entry must come from the first row. So, that is A31. Next. Pwede rin naman, we start with A13. A13, this one. So, sa second row, ang entries pwedeng sa first column or sa second column. O sabihin natin first column. A21, so sa third row, dapat sa second column yan. A13, A21, A32. So may representative from different rows, different columns. Okay, pero pwede rin naman sa A13, kanina A21, ano? Kung A13, pwede naman sa A22. A22, A13, A22. So, sa third row is A31. So, these are the possible arrangements. But the next thing that we will decide will be the sign. And the sign, our reference will be the column numbers. We count the number of inversions so that we can decide whether this is odd or even. Okay, so let's consider this. We have 1, 2, 3. 1, 2, 3. So let's count the number 1, 2, 3. There is a 0 inversion. Okay. So because this is arranged in ascending order, so 0 inversion, 0, that is even, then the sign is positive. Okay, for how about this? We have 1, 3, 2. 1, 3, 2. Let's count the number of inversions. I think there's only 1. Okay, 1 is less than 3, 1 is less than 2, but 3 is greater than 2. So there is 1 inversion that's odd, so the sign is negative. Okay, how about this one? 2, 1, 3. 2 comes before 1. And I think there's only 1 inversion. So 1 inversion, this is odd. So the sign is negative. How about this one? 2, 3, 1. So 3 comes before 1. 2 comes before 1. So there are 2 inversions. This is even, so the sign is positive. Next, oops. Okay, for the next one, we have 3, 1, 2. 3, 1, 2. 3 comes before 1, 3 comes before 2, and no more. So there are 2 inversions. This is even. The sign is positive. And the last one, we have 3, 2, 1. This comes in descending order. So, ilan yung inversions? 1, 2, 3. We have 3 inversions. This is odd. So the sign is negative. So this gives the determinant of a 3 by 3 matrix. So it's somehow lengthy and maybe confusing for others. Pero ganyan yung gagawin, ano? A11, A22, A33, minus A11, A23, A32, minus A12, A21, A33, plus A12, A23, A31, plus A13, A21, A32, minus A13, A22, A31. Okay? So that's how we get the determinant of a 3 by 3 matrix. And ay ma, medyo komplikado po, medyo nakakalito po, papaano po namin matatandaan? So there is another strategy, but that strategy does not really deviate from this definition. Nagkaroon lang ng pattern, and that is through Saro's rule. Okay, sa Saro's rule, paano naman yung process? Taas ko lang to ng konti para may space. And we will compare these two. So sa Saro's rule, to get the determinant of a 3 by 3 matrix, like this one, A11, A12, A13, A21, A22, A23, A31, A32, and A33. So to get the determinant of this, we will extend the matrix. So, augmented matrix na yan. Just extend the matrix by repeating the first two columns. So, A11, A12, A21, A22, A31, A32. Okay, then afterwards, we get the product of the diagonals. Okay, diagonals, ito yung nasa main, this one, and this one. So let me list those entries. So this is equal to A11, A22, A33. So yung diagonal down, ang sign daw, according to this rule, is all positive. So plus A12, A23, A31 plus A13, A21, A32. And then afterwards, we take the product of the upper diagonal. So yung taas naman. So ano yon? So ito, at saka ito. Okay. So that will give us, tapos ang sign, we take the negative sign. So that is minus A13, A22, A31 minus A11, A23, A32 minus A12, A21, A33. Okay? 3, 3. Then when we compare this is Taros rule, ano? When we compare this with the result when we follow the definition, so let's do the comparison. So A11, A22, A33, ito yon, that's positive. Okay, yung mga positive. Ito. The first, then second. A11, A23, A32. A11, A23, A32, the sign is negative. Next, A12, A21, A33, A12, A21, A33, this one yon. And then A12, A23, A31, this is positive. A12, A23, A31, this one yon. And then A13, A21, A32, that's positive. A13, A21, A32, ito yon. Then for the last one, A13, A22, A31. A13, A22, A31. So nandito din, nabago lang yung order, but that will yield the same result because we are adding product of real numbers and commutativity holds. So this will, well, actually, we can use this, mas madali, mas may pattern. We can follow this rule, okay, to find the determinant of a 3 by 3 matrix. So I would like to emphasize, class, that this Sarus rule is only applicable in finding the determinants of 3 by 3 matrices. Hindi natin pwedeng gamitin to sa 2 by 2, mas lalong hindi natin pwedeng gamitin sa 4 by 4, 5 by 5, 6 by 6, and so on. Okay? So let's give more specific examples in finding the determinants of a 3 by 3 matrix. Okay, say for example, we get the determinant of, say, 2, -1, 3, 4, 2, 7, 3, 1, -9. Okay, so following Sarus rule, we write the matrix. Okay, we extend the matrix by copying the first two columns. So 2, -1, 3. Copy 2, -1. And then 4, 2, 7, 4, 2. Then 3, 1, -9, 3, 1. Okay, equals. Okay, we get the product of the diagonals, the entries in the diagonals down. Okay, there's 3. So we have 2 times 2 times -9 plus -1 times 7 times 3 plus 3 times 4 times 1 minus the product of diagonal up. Let me use another color. Say 3, 2, 3, 1, 7, 2, and -9, 4, -1. So minus, is the size. So minus, we have 3 to 3. 3 times 2 times 3 minus 271. 2 times 7 times 1 minus -1 times 4 times -9. -9. So this gives us, we have 6 times -9 is -54. Oh, so sorry, that's not 6, that is 4. 2 times 2 is 4 times -9, that's -36. Okay, 7 times 3 is 21, negative of that, so that's -21. And then 3 times 4 is 12, so plus 12. Okay. Then we have minus 3 times 2 times 3 is 18. Minus 2 times 7 is 14 times 1, that is 14. Minus 4 times 9 is 36. Negative, negative, that's positive, but this one is negative. So still that's negative 36. So this is equal to, teka, puro negative, no? Ito lang ang positive. Ito lang yung positive. So let's add -36, -36, -72. -72 and -18, that's -90. -90 and -21, -90 and -21, -111. 9 plus 2 is 11, no? And then we have plus negative 14. Okay, so negative 1 to 5. Negative 1 to 5 plus 12 is negative 1, 1, 3. So 3, 1, 1, the sign is negative, so negative 130. Okay, so this is, let me erase my scratch. Okay, so the determinant of this 3 by 3 matrix is negative 130. Okay, so that's how we get the determinant. So what are the important points here? Okay, so from our discussion, we were able to define permutation or the arrangement of numbers, inversion, okay, how to determine the number of inversions. And then if we have an even number, we call that an um, even permutation, while if we have odd numbers, that is odd permutation. And in the context of the determinant, even permutation yields positive sign, while odd permutation yields negative sign. No? Okay, then to find the determinant, kinukuha natin yung product ng entries. Okay, we take one entry from one row. Okay, from different rows and different columns. Okay, yung mga entries na nanggagaling sa iba't ibang row na iba't ibang columns. So we take into consideration all other combinations or all arrangements. It's not a combination, permutation na tayo. All arrangements, kinukuha natin lahat ng arrangement. We count the number of inversions or relative to the column numbers of the entries. And then that decides the sign of the determinant, the sign of the product, I mean. Then we take the sum of those products and that gives us the determinant. So basically, that is the gist or the important points on this discussion. And I hope that you understand. I will share this lecture notes. There are still other examples here. And the next discussion will be about properties of matrices. Okay.